Morning, everyone. How you guys doing? Welcome to the third day at Build. Enjoying the week so far? Yep. Come on, that's not energy, right? Yeah. Yes! Hey. All right, now you're awake. Great. My name is Miguel Llopis. I'm a program manager on the Citizen Data Integration team, and I have two good friends with me today, Robert and Oleg. You guys want to introduce yourself or you're asleep?
Well, I'm sort of awake. Hi, I'm Oleg. I'm a program manager at Microsoft working with these great guys. My focus is CDM proper, and we're going to talk about CDM a little later in the deck. I'm just seeding the conversation.
Hello, my name is Robert Bruckner. I'm architect on the data integration team, and I'm also focused on the common data model and experiences across services for it.
We're going to be talking for most of the session about unifying, normalizing data, how you can actually ETL data into Azure Data Lake using Dataflows, as well as how you can leverage CDM, both to shape data, as well as how you can actually extend CDM with new common entities. With that said, let's actually go into the first section, which is just talking about data preparation and the challenges or the realities of data preparation in today's world. First of all, it's really easy to find and connect to data. Data is everywhere. It's easily accessible for everyone. There's many different tools to connect to data. They all work just fine. Data is always ready to go and always in the shape you need. There's never problems with data quality or reconciling data across. Reshaping data is easy to do. So even in the case, very rare when you have to do it, it's really easy. And combining data across sources is also pretty fun and simple. It's really easy to do. Data volumes are small, easy to manage. Data usually only comes from a single source and very rarely changes, so you don't need to handle refreshes and issues like that, right? Okay, I'm glad you guys are all awake. In reality, finding data, it's really hard. Once you find the data source you need to connect to, it's really hard for you to actually gain credentials to access that thing. Who knows who has the credentials, right, for that database or for that network share, who has access to it. The experiences are all across the board, like many different tools from different vendors. They have different experiences. Different data source backends require different query languages. Many tools actually require you to provide a query up front. They're not low code or no code, right? They have a higher barrier of entry, in particular for the average data analyst or the business user who just wants to leverage data to make decisions. Data, in most cases, not to say all cases, has to be reshaped. It's never perfectly in the shape you need for whatever you plan to do. So you need to do a lot of transformations and shaping. The shaping, it's different for each scenario, and it's hard to make repeatable. Combining data across sources is even harder because different data source backend, different query languages, different keys across two different tables that are meant to represent the same. You need to dedupe values, you need to fuzzy match, you need to do many things to actually get your data to align properly. And the last point here is about the 3 V's of big data, which I'm sure all of you have heard. It's not about just the volume, like the size of the data, but also about the velocity at which the data changes. There's sources that change once a year, sources that change once a week, sources that change many times per minute. And the variety of the data, so the differences in shapes, the difference in data source backends that you're trying to connect to. They all make data preparation and data acquisition really challenging for the average user today. Now, to make problems even worse, different applications within your organization may store data in different silos, making it even harder to access and combine and reconcile. So this is just an example with different systems for mobile and web applications, transactions, IoT, data, social, marketplace, and so on and so forth, each of them on their own silo. That's where, of course, the notion of a data lake or a unified storage for all of your data comes into play, but that comes with its own complexities. How you actually normalize that data, make it easily accessible, discoverable, correlate data in the right way, make sure everything is consistent. There's a graph of knowledge here and information, as you see captured in the image, that sometimes it's really hard to navigate. So we're here to help. And how do we help? Actually, before helping, let's actually take a different look at this from specifically BI solutions and analytics solutions. In traditional world, you have OLTP systems, and that you want to make accessible to your end users through reports and dashboards just to get some insights and make decisions. The in-between, traditionally it's been where data warehouses made into play. Now, in order to make that work, you have to pull significant effort, also with data lakes. The effort comes into how you actually prep and ETL data and reconcile it so that you can actually populate your data warehouse or your data lake. There's, of course, the scenario of defining cubes and analytic models that users can access from those reporting tools. But this is not self-service. It requires somebody to actually go and set them up so that the end users can access it. To the point that it requires a significant amount of work on IT or analytics departments that by the time you're able to set up that for your end users, the business has moved on. Just, the question they were trying to answer is no longer relevant to the business, so your work is pointless. You're welcome. Well, this is actually the sweet spot for self-service BI, right? Serving through a cube or through a data warehouse, a set of metrics, measures, dimensions, and other concepts that users are able to leverage to do analytics. On the other hand, there is the prep work that goes into populating those systems. And the notion of self-service BI also implies that you can access the underlying raw data sources, but then you run into all of the challenges that I was mentioning with differences of sources. And why would you give end users access to the raw data if you can actually give them access to curated data? And the challenge with that is you become the bottleneck to curate that data. But if we give you the tools that help you be super efficient on that, or that even help the end users or some advanced end users to curate data for many others, then it actually takes pressure off of you, and it helps democratize that task to prepare and normalize that data and get it into a data lake so that they can reuse. More so, you've probably seen this quote before, analysts spend about 80% of their time just doing data prep before they can even do analysis and decision making, which is really what they're after. How can we help you with that? How can Dataflows in particular help you with that? How many of you are familiar with Power BI? And how many of you have used Power BI Dataflows already? Okay, about half the room. That's good. So Power BI Dataflows is nothing but a set of capabilities built around Power Query and the Power Query Online capabilities and many other components that you're familiar with from Power BI world. For example, the on-premises data gateway and the connectors, so that you can go and define those entities, define those ETL pipelines that get some raw data and refined along the way. You can map with something like the common data model, which we'll show you. So that you can land data into Azure Data Lake Storage. And not just you, but your business users and your classic data analyst is able to do this because there's just leveraging tools that they're used to. If you use Power BI Desktop, if you use Excel, if you use Power Query, they'll feel right at home because it is the same set of capabilities. Now, this picture actually is a subset of a picture that these guys will show you later. This is just the lower end of the spectrum where we enable data analysts and low code, no code scenarios through Power BI to ingest data into those ADLS folders, in this case CDM folders, which we'll talk more about. This is kind of what I was talking about. Dataflows use Power Query. We support about 45 connectors right now, a combination of cloud and on-prem through the on-prem gateway. Same set of data transformations as in desktop. There's about 300 plus transformations. The UI, although web-based, it's very similar. You'll see the same concepts apply in Power Query, the same main elements. And with that said, enough talking. We're going to go and do a couple demos. So we'll switch to number 6 here. So what we're looking at is powerbi.com. I'm in one of my workspaces, and I've moved to this new tab called Dataflows. So this is where the workspace views, where you'll see all of your artifacts in this workspace. We just recently added a few months ago this Dataflows tab. And now you can go to Create, and here from Create, now you do have this new option to create a data flow. So we're going to go do that. I do have 3 options here for how to create a data flow. The first one is defining new entities. So this basically means connect to an external or raw data source and do some Power Query-based transformations to ingest data into the lake. The second one is to link to entities that somebody else or even myself has already loaded into the lake, so you can actually compose entities on top of entities within the lake. And we'll talk a little bit more about that. The third one, which these guys will also talk in depth about, is attaching an existing CDM folder. So you might have created a CDM folder with another tool, maybe with Azure Data Factory, maybe with machine learning, maybe with Databricks. And that data that's already sitting on the lake, although not ingested through Power BI, it can actually be reused from Power BI as well. Let's actually talk about the first path, defining new entities. And here we'll put you into the Power Query online get data experience. So as you can see, this is Power Query right here. We are going to actually connect to an OData feed. Many of the connectors you'll see here you'll recognize from Power Query in the desktop. So many files, many databases, Power BI Dataflows itself, so you can actually reference back to entities already ingested, Azure services, other online sources, and other few more sources. So we'll connect to OData. My favorite OData feed in the world is Northwind, so I'm just going to grab that URL. This is, in this screen, this is where you would pick the on-premises data gateway if we were actually connected to an on-prem source. These are all the gateways that I have accessible to me from Power BI. Now in this case, because it's a publicly facing internet or data feed, so I don't need to assign that, and I'll just use authentication kind anonymous. When I click next, we're going to go into the navigator screen. Here is where you can browse and see the, in this case, the entities or the tables accessible from OData. And you can preview them and select one or multiple. So we're going to select customers, and we're going to select order details. And we're going to select orders as well. And the network is a little bit sluggish, but that's fine. We'll move to next screen. Next screen after you selected your tables is the Power Query editor. And now the three entities I selected, customers, order details, and orders. What I'm after is actually building a single entity on the lake that's going to have information about our top 20 customers based on their orders volume and the overall sales per customer. In order to do that, we have to do a little bit of data prep. We brought these three tables. Now, order details has lines of order. If you look at each of the lines of orders here, we do have the order ID. And now, for example, for 10/2048, we have 3 lines of order. And then we have the product ID, and then we have unit price and quantity. I'm not going to give any discounts today. So the first thing we need to do is to actually calculate the line total. If we select unit price and quantity, we can go and add a new column with a standard operation like a multiplication. And now we end up with this new column that has the line total. Great. So now that we have totals for each of the lines, we need to calculate the order total. So we can go pick the order ID, and maybe we do a group by. And here we can call the new column order total. The operation we're going to do is a sum, and then we pick which column to sum. We'll pick line total. And that's going to give us just the 2 columns with the order and the order total. Great. Now we can go to the orders table, see what's up here. This is a table that holds the order IDs together with the customer IDs. And it's the one we're going to use to ultimately do a join with customers. So we'll just keep these 2 columns. We can remove the other columns. And then we're going to do a merge in Power Query terms, or a join in database terms. We're going to merge 2 queries. We're going to merge the current one, orders, with order details. And we're going to use the order ID column for both. Here's where we could select different join kinds, different types of join. We'll stick to left outer join. Great. Now that we've done the join, we have the order details column. That holds all of the nested columns from the other table, from the order details table. The only one that we're interested in is order total, so I'll just uncheck the ID. And now we have, again, the same order total together with our customer. Now the next thing we need to do is calculate the total spent by a given customer across all their orders. To do that, we can just do a group by customer ID. And we're going to call this total. And again, it's going to be the sum of the order total column. Great. So now we have customer ID and their total spend. Now let's go to the customers table. And here we can pick a subset of the columns. We just pick the customer ID, the company name, and then we can pick maybe their country. We can remove the other columns. And then we are going to do a join, or a merge, and then we're going to bring from the orders table, matching on customer ID, we'll bring the total. So then we expand just the total field. Great. So now in order to get the top 20, now we have the actual table shape that we want to expose, but we just want to get the top 20. So let's just sort descending. And then we can remove, or actually keep the top rows. We'll keep the top 20 rows. And this is our top 20 customers. So we can rename this query to top 20 customers. Now this is the final one that I would like to load and ingest into Azure Data Lake Storage. what I'm going to do is right-click on the others and then say disable load. And when you disable load, you see that the query actually switches to a gray and italics format here, as opposed to the top 21 that remains the same. If I click save and close, now we're transcribing these queries to become the actual entity definitions. In this case, because I disabled load for 2 of them, there's just going to be one entity, and it's asking me for a name. So I'm going to call this build session. It's asking me for a name for my data flow. And then it's just going to show me the one query. And I can click refresh now or set up a scheduled refresh. So I'll just click refresh now. Now, this entity actually just calls out the fact that I have these few columns in here, and these are the data types that are going to come for each of the columns. Now that I've created this entity, what I can do is share this data flow with my other coworkers, people who are using the same workspace in Power BI, and now they can reuse this entity from many different data sets and reports. How they do that? They use Power BI Desktop. Power BI Desktop is the main report authoring tool for Power BI, right? So what we've done there is, if you go to Get Data, we've added Dataflows connector under the Power BI tab. And from this Dataflows connector, you're going to be able to access all the data flows and all of the entities within those data flows that you have access to across all of your Power BI workspaces. So the first thing that I see here is all of my Power BI workspaces. I was actually using the Dataflows Premium one. And the data flow that I created, it's called build session. And within that one, there should be the one entity with top 20 customers. And I have all the data there. So from here, I can do the usual stuff, right? I could either reshape and transform this data or just load straight and build my reports from here. So for example, if I just do a load, maybe from here, I can do something like building the number of top customers by country. So we can do something like the count of customers within those top 20. So we see that most of our most active customers are in Germany. We have 4 of them and 3 in the US. And that would complete the end-to-end. Now, the demo I showed you, it actually shows how to build a data flow from scratch against a raw data source. We're bringing in much more sophisticated capabilities that will allow you to reuse stuff out of the box, leveraging the value of CDM. And this is where Robert is actually going to show you a demo for what we mean by that with Dataflows templates.
All right, thank you, Miguel. So you saw Miguel going through doing self-service business intelligence, connecting to different sources, shaping the data, transforming it, and deriving insights, right? And there's always a need for doing that. But I'm sure some of you in the audience, and maybe a show of hands, are also in the business of wanting to build applications that are packaged, that your customers, right? Maybe you're an ISV, and you want to build some prepackaged applications that your customers can easily deploy, right? You're selling maybe not to the IT organization, maybe you're selling to the business units, the business decision makers, and you want to make it as easy and simple for them to just acquire, right, your application and, right, configure it. And ultimately, for your application, you want to leverage some of these capabilities that were just shown. And this is where, right, some of those aspects come in. And so an example of an application is, right, packaged application could be customer service insights. There's similar applications for sales insights over, for example, giving you insights over your sales pipeline from Dynamics, or customer service insights giving you insights over your support calls and, right, your support agents and how well they're doing and what is the feedback from customers. Now, this application, and let's see, right, here is the application kind of available, right, to basically look at live data, right? And so you can have this analytical application where your customers can simply sign up, right, and have this populated. Now, it would be nice if this application would work over multiple different types of sources. And in this particular case, right, so what we have publicly available is this application can be connected to, if you have a Dynamics 365 environment, but you also see there's other options coming, right? And one of them is Salesforce. And so how would you go about building such a thing where you have a singular, right, BI application where you can leverage some of the things that we showed you as an application builder and ultimately make it work over multiple different types of sources? And so this is where we ultimately go back here, and I'll, right, basically now I'm playing the role of I'm a developer. I want to leverage something. Instead of starting from scratch, I want to leverage something that maybe somebody else has already built. And so what you see here in the bottom part is the section of templates. And templates are basically connectors plus prepackaged transformations. And the prepackaged transformations are transforming your data to particular destination data shapes. So if you think of this customer service insights application, it has the notion of support cases. It has the notion of customer accounts. It has a notion of maybe a sales history. So you understand, are your customers who you sell the most, are they actually happy? So you have these kind of stronger concepts that your BI application wants to reason over. And so what we have done here is we actually have some of these prepackaged templates available that bring certain areas of data in this case, for BI purposes. Now the one, for Dynamics 365, underneath, the way the data is described is in the common data model, So if I would just pick one of those templates, it would allow you to do in a single click, bring certain subsets of sales engagement related entities or maybe customer service related entities into your workspace here. But I think the more interesting one is probably looking at Salesforce data. Salesforce has ultimately a different shape of data underneath than what you would find in Dynamics. And so I'm just logging in. And so what you see here is that I connect to Salesforce, but I actually have a set of predefined queries here. And so if we look at this, this particular template has predefined queries for accounts, for contacts, for leads, opportunities, products, and several more. And also what it does is it also has basically predefined transforms, of how the data ultimately, how the connection is being made, how the data is transformed to a particular destination shape of data, which then, for example, the customer service insights application or the sales insights application can ultimately just bind its BI model to and basically operate exactly the same way with Salesforce data. Now, some of these transforms are not just mapping and structurally, this is why you see also there's ultimately data transforms. And there's also a step here, where there's a certain list, of standard entities that we have basically available, documented publicly, And there's also the mapping template basically predefines, for certain areas that are important, and can be extended, but it predefines certain mappings to these standard entities and to certain fields within the standard entities. Now, as a developer, I could just go ahead and use this template as is. I could also write just further. This is just Power Query. I can do further transforms on top of this, But basically, without writing any code, without doing any clicks, I can actually get started with basically these prepackaged templates that provide me data already in a certain, more business-oriented shapes for my applications I want to build. Now, where we're going with this is, so I could use this and then do my BI applications. Where we ultimately want to go with this is, you saw there's a few templates that we have already in this experience. We want to go further and open this up, for all developers. Some of you in the audience, maybe a show of hand, who has already used the data connectors, extensibility that exists with Power Query and build your own connectors. Okay, we have a few people in the audience. So we are basically doing similar things along this path where, okay, you can build your own data connectors beyond the connectivity that exists here and plug them in. You will then also be able to plug in your own templates, to package not just the connector, but actually package further transforms on top and make those available to your customer. So that ultimately, you can use it for your own applications, or you can distribute this to your customers more easily. So with that, let's basically switch back to the deck. And so just a quick recap of the common data model, of one example of how it's in use in Dataflows. It really, the way it showed up is, was part of this prepackaged templates where, as one of the steps, it also maps to one of these well-defined standard entities that have a certain context of meaning, such as a sales order or a contact or a lead and opportunity. You can, of course, also define your own custom shapes. And you can also always use, outside of templates, you can already use this mapping functionality, This map to standard that I showed is just another step. It's just another transform in Power Query. Now, what we did is we ultimately leveraged Power Query for doing all these transforms in a no-code fashion, and ultimately enabling you to get things done very quickly, but when the UI may be not sufficient to do everything you want, you can still write your expressions using the M language. Miguel didn't show an example of this. He did all these things through the UI, but you may have seen there's a formula bar, and through the formula bar you can write Excel-like formulas and do your calculations. Ultimately, you can map those things to some of these standardized data shapes, and those can be then used by applications that specifically want to bind, let's say the Sales Insights application specifically wants to give you insights into your sales pipeline. To do that, it needs information about sales orders, leads, opportunities, customer contacts, and different products that you're selling. And so it can basically build this pre-packaged dashboard experience and just bind to data, whether it comes from Dynamics or it comes from another system. As long as the data is landed in that shape, that application basically can work over that data. And so with those out-of-box templates, we ultimately will make this easier, so that you get even faster time to value. So with that.
Yep. A couple more concepts on data flows before we move on to the CDM-centric part of the session. Data flows are like Excel. And what we mean by this really is that you can actually compose data flow entities on top of data flow entities. And when you do that, we take care of all of the orchestration logic behind the scenes to keep things consistent. If you think about Excel, how you use Excel and a spreadsheet today, it's really intuitive to you how you go into a cell and you type equals 1 plus B2, for example, the cell B2, whatever content is in there. And then you go to B2 and you modify the value in there from 2 to 3, and then you see that the other cell changes to 4 automatically, In concept, that's what we're doing with data flows as well. You could create an entity such that it links to another entity or it computes data on top of that entity. And the moment that the original or upstream dependency entity changes, we'll take care of refreshing all of the other ones. So it really simplifies the orchestration logic. So really, there are two things that I really like about data flows. Number one is that users, data analysts feel very confident in using it because they're used to the experience through Power Query. And the second one is that it actually simplifies that orchestration logic that before data flows, it was only available and something that only a pro ETL developer could actually do. A little recap on data flows. They're based on the new Power BI capability that's also coming soon to the rest of the Power Platform soon, and stay tuned to this for the next few months. The concept there is that Power BI should not be the only tool where you can actually create these data flows. If you wanted, for example, to use Power Apps or Flow, or you would like to leverage data from the lake within your Dynamics applications, you'll be able to use data flow capabilities within the rest of the Power Platform as well. They're built on top of a Power Query experience, and they allow you to ingest data onto Azure Data Lake Storage Gen 2. They leverage the CDM folder format. We'll talk a little bit more about what that means. And you can map to CDM entity shapes along the way as part of that data prep. It's a tool for business users that allows them to just create these entities on the lake for greater reusability across data sets and reports within Power BI, and very soon Power Apps and Flow artifacts as well. And they enable this Excel-like lineage and orchestration of data with reference entities and so on. They're not a replacement for data sets. They build on top, or actually data sets are built on top of data flows in the sense that you link to data flow entities from data sets. They don't replace data warehouses. There's always a place for those things. This is more for a self-service, agile data preparation that doesn't involve, a pro developer or a pro ETL developer or a BI solution expert to actually develop a data warehouse. They don't replace Azure Data Factory or SSIS for the same reasons. You can use those tools as a pro developer, and there's that complexity needs to be handled as well. But data flow should go a long way into minimizing the amount of times where you need to actually go embark into a complex project such like that. They're available across Power BI SKUs, including Pro as well. There's some premium-only features that I didn't get to demo, but some of the link and computed entities capabilities that I showed, they're bound to a premium license. But for the rest of it, they're just part of your regular Power BI subscription. They don't have any additional cost. And the last one, which drives me nuts, they're not spelled with a space or any capital letters. So Dataflows, lowercase d. With that said, maybe we can do a little round for questions on Dataflows before we move on to CDM. Any questions? Question in the back?
So this data flow is totally different than data factory data flow. It just happens to have the same name.
Yeah, the question is, this data flow is very different than the data factory data flow, but just happens to have the same name, right? Correct. So think about them as they target different personas. Azure Data Factory is a tool for advanced ETL professional developers to create orchestration logic and pipelining and data movement solutions. What we showed here is a low-code or no-code experience for data analysts to ingest data into Data Lake. So yes, depending on the persona you are and the kind of complexity you want to use, you'd use one or another. It's very rare a single person would use both. Yeah, question?
When you say you refresh the data, do you stop appending data? And so how do you manage aggregations?
Yeah, so the question is about refreshing data and appending data. And yes, we do support incremental refresh capabilities. I didn't get to demo, but as part of loading an entity, you can then go and configure the incremental refresh policy. Like, for example, based on a date column or something else, you can define what those partitions should look like, that partition logic. Yep. Okay, over there. Sorry, he moved me away.
So I noticed, like, when you connect to Salesforce, you specify your account for it to refresh automatically on schedule. I think that needs to be on the service account or something like that. How does it refresh in the background?
The question is, when we connect it to Salesforce, we use an account that, does it need to be a service account or a system account? And the answer is no, it could be a regular user account. It doesn't require any admin privileges or anything. This will pull data as of that user's permissions. So be aware of that as you share this entity or this data flow with many users. One more question, sorry, he was first, and then we can take more at the end. I just want to make sure I don't need on their time. Yeah, so the question is the templates that we showed, is there any notion of a marketplace and so on? So right now, these are templates that Microsoft builds. There's no need for that marketplace, but we plan to open this up, not immediately, but in the long run to third parties, and at that point, we will make sure there's discoverability and market integration. With that, I'm going to hand off to these guys for the CDM section.
Hey there. Morning. Interesting so far? How many of you heard of common data model or the CDM?
Well, at this point, they've heard you.
Yeah, that's coming to it. So a little trivia. Is CDM a server, B, an operating system, C, a data model?
B.
All of the above. Great. That shows the multiple choice training. Yeah, the CDM is a common data model, and you've heard enough about it already to build up some interest. And you heard it in the context of mapping to an entity, or entity helps you understand a data better. And in a great build-up to the content that Miguel did, basically showed you the slide that says, yes, data is in silos, data isn't intuitively understood, and it's difficult to actually figure out what you have on your back end when you connect to a data source. So then when you want to build analytics, you want to build reports, you need to have more than just a DDL level understanding of your data. So you basically have the column name and data types, and that's basically a good luck figuring that out. And especially when you go a few layers removed to an analyst who may not necessarily have intuitive understanding of your backends, you want people to build reports operating off of the real semantics. And this is where CDM comes in to help. So we build basically a shared data model that allows applications and data integrators to easily interoperate. It means that you can preserve semantics through all your pipeline. So it's understood to a person who does the data prep, as well as to the person who does the reporting at the very end, or actually consumes the reporting. So it includes a rich metadata with standard entities, relationship, hierarchies, traits, and more. So basically, it's the data model. It's a standardized language that allows you to describe data in a standard way. So you don't have to reinvent the wheel every time you want to describe a customer table or some table that originates from some other source. Not necessarily a table. CDM doesn't limit you to relational, transactional-oriented data structures as a source. You can apply CDM as model language to describe IoT data, clickstream data, highly unstructured data. It doesn't really matter what your data source really is. And you may ask a question, where did it come from? Yes, it originated originally, and Robert, by the way, the man behind this whole CDM initiative, from the D365. So you will find the standard entities very resemblant of the CRM or the Dynamics 365 there where the concept got from. And we just amplified it and made it available more widely than just for Dynamics. And multiple systems and platform implement CDM today. You've seen some of it demoed today already. So you can use the CDM. If your source is described in terms of CDM, it's easier to understand. Or you can use CDM as definition of your targets for your data load, so it is understood on the other end. So that's basically a brief intro to what the CDM is, and it takes some time to kind of digest. It's not entirely new concept. I bet all of you, how many of you in your organizations decided to do some standardization across data? Great. So you say, thou shall always use that shape of a customer or the account. Yes, but now guess what? It's not only constrained to your organization. So if you have a vendor, a customer, or any ecosystem consumer of your data, they don't have to scratch the head or have a gigantic meeting for you to explain them what it is. They can, A, inspect the entity if you define it that way. And more importantly, as we bake CDM more into all our tools and through our the ecosystem of our apps, it becomes programmatically understood by code that runs different systems. So this is how the CDM folders interoperate in the modern data warehouse. And Miguel, if you recall the slide, Miguel had shown you kind of the left or the other left. It depends on how you're looking at it. So the first portion of it when it has Power BI. And you see the ingest part. That's what he did. He did the connected to the source, did the prep, ingested it, massaged it, made it meaningful, and then pushed it into the CDM folder, the thing at the bottom, into the Azure Data Lake. Once it lands in Azure Data Lake, you can use all Azure machinery to process your data. And that comes in very handy if you want to do sentiment analysis, machine learning. You can do all these things using the Databricks and the ADF and the other data management tools and machine learning, and you don't need to interact with it all time in a real time, because CDM has attributes and traits, extended metadata that can instruct your processing systems, the data processors, on how to treat data. So that's super powerful, because now you don't have to do the human intervention every time and figure out what does the address mean or what does the city location mean. So that's super great too. And before we go to this, I can actually, can we go to 6? Sure. Yeah. And this thing, oh great. Miguel, make sure it's yours. So we have a little, it shows you that we don't have it all orchestrated. That these are not holograms of people. This is actually live. So.
Little funny story. When I set up this machine, I actually didn't shave, so it recognized me with hello. The following week, I shaved, came in, it didn't recognize me. I had to rerun the tool again.
That's why I never use that. I type in the password.
You don't have that problem.
Well. So the thing that you've seen in a text, it's great. You see the text, it's beautiful slides, etc. Now this is more of a, it's hard to demo the object model on the metadata, because short from just showing you the big JSON files. This is the actual entity navigator, and you'll find a link provided in this deck. There is a specific link to the entity navigator. It's public information. It's available from Microsoft's site. That shows you the GitHub repository of standard entities that Microsoft had published. When I use word standard, folks immediately get alerted. Is that the only way you can use CDM? The answer is no. We provide basically a reference data is the standardized view of metadata that you're welcome to use. As in reuse, you can also extend because CDM is a metadata language. It's a standardized metadata language. If you see that our understanding of account doesn't have your favorite pet name and you feel an urge to have it there, feel free to extend it and use it in your organization. Here, it shows you the few of the concepts here. So, for example, I selected the contact, and you can see that I have all attributes that I can click and inspect, and I can also do, per each attribute, I can use traits. I can see the traits, which are like adjectives. They further describe your data. You can create all of those traits and all of those attributes. You can expect the properties. You can see with color, and we can debate whether it's most ergonomic way to use the color, but you can see that the contact, for example, and account are used interchangeably. So you use one to reference the other. So going back into the, so that basically shows you how we reflect this in the CDM. So you basically have entities, you have set of attributes, which is effectively, you can think of them as columns, but those attributes can not have only the data types, but they can also describe what the attribute means, and there are traits that we also use to enrich the semantics. So you effectively see the address city means location city in the address one city. You see that's what the illustration of the power of the CDM. So it's not just a address one city or address city. It means the location of the city. See that? So I can say is used or is nullable. So you have traits that apply both to kind of the mechanics of your system. They apply to what values can it have, but it also gives you the understanding of what data really means. So it's not just miles or kilometers, it's distance. So that will go back into the slide that I showed before. Now all your Azure ML and AI can pick that up and process it with more fidelity and confidence. Having said that, we'll transition to.
So, the common data model is a modeling language. It also has some of these standard models that are already published. But really, the common data model is a means to an end. And what I mean by that is, it's to get certain tasks done easier. And so when you think of it, any complex application that you build, you really have different kinds of personas that probably need to achieve the result when a certain business question is asked. And how do we enable those different personas that all have their favorite tools, The business analyst maybe uses Power BI, The data scientist uses machine learning, And then you have, your developers that want to write code, And maybe want to use, Spark and Databricks and so on. How do we enable them to really collaborate over ultimately answering a business question where you have some data that comes from different systems, and then enrich it with more data. And the business analyst, yes, they can get certain things done in terms of Power BI and the no-code, low-code experience. But at some point, they may need to talk with their data scientist colleague because they need a machine learning model. And so how do we enable the business analyst, whatever they have already created in Power BI, to be usable directly by the data scientist, and not just usable in the sense of the business analyst sits down with the data scientist and spends an hour and talks the data scientist through, well, here's where this data comes from, here's the Power BI desktop file, maybe that I've created, the data model I've created. And the data scientist is like, well, how do I use this data model with my Azure machine learning tooling? And so what we have done is, we have focused on how do we enable the spectrum of different tooling to better interoperate, so that when what the business analyst did with Power BI and bringing data into the data lake is not just a raw data dump, it actually has a lot of metadata associated with it. Now that metadata sits in the background, so when the data scientist comes in and uses Azure machine learning and points to that location in the data lake, there's actually certain things that will happen automatically. So one of the common things is, As a data scientist, first thing I would do is I would have to create my pandas data frames. That is a tedious task. Or if I use Databricks, and first thing I have to do is I probably create Spark data frames. And so when I create them, there's certain, I have to look at the data and try to understand what the data is about, or rely on auto-inferring with the metadata that we basically have placed right next to the data in the data lake, the so-called CDM folders. In Databricks, we can auto-generate the data frames for you as a data engineer. We can auto-generate the pandas data frames as for the data scientist. So it's not just a time saver, for the engineer to do this. It actually also enables the engineer to just start basically working from where the business analyst left off. And then the data engineer, or the data scientist creates more insights. Those insights ultimately also land in the data lake. The result is a CDM folder. Now the analyst using Power BI can go back and simply connect to that CDM folder and really take advantage of some of that additional metadata that is next to the data. So the business analyst doesn't have to reinvent understanding the data, understanding some relationships among the data, or understanding some of the semantics that is associated with that data. And so what you see in this picture is that we have ultimately this is a journey, We want to enable many, many different tools, and of course also lots of ISV partners, of how they can benefit from this, either as a consumer of these CDM folders and plugging into supporting these different personas in their daily job, or also when they process the data and write the data back in the data lake, how can it be more easily, with lower friction, leveraged through other tools that exist in this ecosystem. And so you saw today Power BI Dataflows of how you can connect to data, bring it into underlying the storage. The way it's really stored underneath is actually a CDM folder, which is the data plus metadata. Now, you can then use things such as Azure Databricks, or Azure Machine Learning, or Azure Data Factory, or SQL DW. And there is a tutorial that I will point to. Actually, let's switch to this machine. And so this is a tutorial that is publicly available that you can walk through by yourself. So there's libraries we have released that are basically an object model of the common data model for multiple languages. And you can basically follow along this path here, So what the diagram shows is what the tutorial ultimately does. You start with, you have your own database, Your own, maybe your business data. You use Power BI, you bring that data, you connect to your data, you bring it into the lake, and then you use Azure Data Factory and use Databricks, Databricks ultimately to do further transformation, further enrichment with another data set. And as part of that step, you will see that you simply point Databricks to the folder that Power BI had created, And Databricks will basically automatically understand, oh, this folder actually contains multiple data sets. There's relationships between that. It will auto-generate the Spark data frames for you. Then you may implement your processing job. The result of your processing job again ends up as a CDM folder that has metadata associated, which you can then go to Azure Machine Learning. From Azure Machine Learning, you can create a machine learning model over your data. The result, again, is something that you can then use, for further processing. And ultimately, in the tutorial, you will create a SQL data warehouse, And when you create a data warehouse, it's all about, okay, in what sequence do you load tables? Because, because of relationships and otherwise, there's probably a certain sequence, in how you want to load the data. Well, with the metadata in the CDM folder, that task is also being simplified. And so it will actually help you with some of these tasks. Instead of manually designing all those steps, it will actually help you simplify some of those. What you see in this tutorial today, you can walk through it. There's basically code libraries associated. It has step-by-step guidance, screenshots, everything. What you will see over time is that even the steps that are there today is already simpler than what you would have to do if you were to try to accomplish this without any of those libraries that we've already released. But we are ultimately aiming to make this built-in functionality across all these services, so that if you were to do the same tutorial, let's say 3-4 months down the road, you would actually do even less manual steps. So it's basically the idea is that we have more and more built-in functionality across multiple different services that take advantage of the metadata, that natively produce the metadata on all the steps that you do, so that you really, as a data engineer, as a business analyst, as a data scientist, you spend less time on the repetitive tasks where you create data frames and those kinds of things, and you spend more time on actually really focusing on, okay, what is the insight? What does the data tell you? What is the machine learning model? What did it find? You spend really time on creating business value. And so with that, let's switch back. And so ultimately, this is the journey that we're on. We are also working with partners in the industry. In the keynote, you probably also heard about work we're doing as part of the Open Data Initiative with Adobe and SAP, but we're also working with other partners, and there will be actually announcements in a few weeks by one of our big partners that basically has implemented CDM folders as part of their product line, and how any data that is basically processed and landed through the partner in Azure doesn't just land as raw data files, it lands as CDM folders, and how their tooling basically can understand the metadata from other CDM folders produced by other tools. And so you will see more of these things coming over time. Now, if we take a step back and look at, okay, the world of business applications, and so and especially the Common Data Service and Power Apps as the no-code, low-code experience for building applications, the Common Data Service underneath implements Common Data Model today already. And it has a no-code experience of how you can build business applications that are more around business transaction-oriented. What we also have is we have a number of these insights applications. I showed one example briefly, the customer service insights, the sales insights, custom insights, several more, market intelligence, and so on. A lot of these underneath, what they use is actually the kind of approach that I showed here, which is there's an Azure Data Lake, there's Power BI Dataflows. They just wrap all of this up programmatically to give you a no-code experience for business users. But because they leverage all these capabilities, a lot of these applications can be then further extended, of bringing additional data sets into this, and then also bringing the insights that are generated as part of this back into driving and automating some of your business processes that you may have already running in terms of a Power App, a flow that automates business processes, or a Dynamics 365 application for your sales engagement, where you have some of these existing processes that maybe today are triggered by manual intervention, like a customer calls up the service center, and then based on what the call is about, it may trigger a field service agent to visit the customer to perform a repair. Well, a lot of this, based on additional intelligence that maybe can derive from sensor data, from IoT data, can be basically can become predictive maintenance, where you don't have to wait on the customer to call. The business process already exists, of how to schedule a field service agent to visit the site, but you can do it based on that signal. And so this is ultimately where underneath, the way we accomplish this is we actually leverage a lot of the Common Data Model of how we put all these things together underneath. And we're certainly working towards how to enable developers, partners, to do the same thing, to benefit from all of this as well. And so just a quick word on the Open Data Initiative. This is where the CEOs of Microsoft, Adobe, and SAP ultimately announced that, well, in this world where you have more and more SaaS applications, it becomes really difficult to really derive value across all these different SaaS applications. And so the principles that we're actively working on across the companies and with customers is the enterprise customers should have it, they own that data in those SaaS applications. So we want to make it really, really easy to make that data available for their own machine learning at scale, for their own intelligence they want to derive from that data. And we also want to break down those data silos so that we don't have just every service has a different way of connecting and how you get the data out of it, but rather we ultimately provide you out-of-the-box mechanisms of how do you get that data out of those systems, and when the data lands, it's in a single data model with single semantics, where it's very clear that sure, there's a certain attribute that has a certain name, but programmatically, there's metadata that tells you this is supposed to be a phone number. This is supposed to be a geolocation. right? And knowing that programmatically through this traits mechanism that we mentioned earlier, that allows, right, then to, right, different applications to reason programmatically over this, where you don't need, right, human intelligence and a subject matter expert of, right, all the systems that you connect to that you want to, right, combine the data from, to really understand, oh, attribute, right, 1, 2, 3, well, for this application, it means, right, really this. No, it's encoded in metadata. And so that will just accelerate deriving value from this, including when you create machine learning models. You don't need to spend CPU cycles on rediscovering, well, this might be a phone number. No, you know for sure, based on the metadata, this is supposed to be a phone number. And so you can just much faster derive value from this. It's also ultimately open and extensible, right, for, right, basically additional systems. So it's very much designed around making this a common data language, with common concepts, right, that really enables this automated processing for all these different, right, wide-ranging user experiences. So it ultimately, right, that the different tools that the different users may use, right, be it business intelligence tools, be it machine learning tools, and so on, that those take advantage of that, and ultimately also backed by a set of, right, well-defined out-of-the-box data models that, right, some of these SaaS applications will, when right, the data lands in a data lake for analytical purposes, the data is automatically reshaped into those, right, common data models. Now, the existing SaaS applications, they have, right, an internal data model and so on, right? They will continue to do that. It's just, it's an additional option of how these SaaS applications will land the data pre-transformed and with very rich semantics, so that it's so much easier to ultimately derive value from this and have much faster, ultimately, insights from that data across what is otherwise really silos of data. And so with that, I just want to summarize, right, some of the key takeaways. The common data model, right, is really focused on how do you get faster business value out of this. Yes, you can look at this as it's a modeling language and so on, but really what we are focusing on is how do we also enhance different services, different tools to take advantage of these things, to make certain steps automatic that otherwise today, right, are just introducing friction or, right, introduce lag time of, right, basically creating value and answering the business question, right? As Miguel said in the beginning, by the time, right, today some of these questions maybe get answered, well, the business has moved on, right? So they have already been dealing with the next question, versus with this, we really want to enable, right, closing, having much faster inner loop around there's a question that pops up, how do we enable even the business users to answer more questions themselves, but for certain things they need help, right, from data scientists, they need help from data engineers, how do we enable them to collaborate so much more effectively? And CDM is kind of sitting in the background and helping and facilitating a lot of this so that when they collaborate across tools, there's actually metadata that travels across so that you don't start over and rediscover and figure out, oh, what does this data set mean? And so we showed you, right, specifically implementation in terms of Power BI Dataflows, but you can use it in the common data service today in the context of Power Apps, for example. There's the tutorial that ultimately is publicly available that you can walk through at your own pace that, right, delivers a whole end-to-end scenario across multiple different services and touching on the business analyst persona, on the data scientist, and on the data engineer. And so with that, in terms of the call to action, right, here's a couple of links. So you can, right, specifically learn about Power BI Dataflows and what is available today. You can learn about the CDM, the metadata language, and the standard entities. Also the tutorial in particular. There's the link where you can, right, follow through step by step and perform all these steps. And as I said, we are continuing to develop this and ultimately make a lot of this built-in functionality across multiple different services. So the steps that you see today, they will continue to shrink in terms of what you would have to do manually to achieve that same outcome over time.
For those of you taking pictures of the presentation here, the deck will be uploaded after the conference, so you guys can take a much better picture of your laptop.
Yes.
It's hard to take a picture of a URL which is obscured by the...
Yes. And then ultimately also links to the GitHub repository that we briefly showed, where you can ultimately find object model, where you can find, right, some of these standard definitions and so on. So with that, we want to basically open it up to Q&A. We maybe take a few questions. There's microphones here in the room. And then also, we can also take it offline for a few more minutes after the session.
And we do have a booth on the expo area. If you want a CDM poster, stop by and grab one or two. Thank you.
All right. We have a gentleman here.
Very good presentation. So 2 questions, if I can. The first one is, if you want this semantic information to travel, it seems like every application and every end user who's doing a data transformation might need to do some work to pass on semantic, metadata about the transformation they just created. And is there a mechanism, either tooling for that or aids for users to do that? And then can I jump to my second question, which is kind of subtle? I don't want to just know this is a phone number or this is an email address in one field. I want to know for this product, the user's pointing me at this product, and I'd like to know that it's when it's dimensional data, that this field represents a product and the set of products, and the products are over regions or over business divisions or types or something like that. So is there metadata in the CDM to represent that information? So in a software tool, I can go in and see that whole structure of the data.
Okay, so I think on your first question regarding some of the tooling, how does it take advantage of the metadata, and how can you further enrich that? So what you will see is that there's already in the tutorial, you see examples where we take advantage of the metadata of simplifying certain steps, automatically creating data frames, and by taking the information out of what is in the CDM folder, the metadata, and populating data frame metadata in Spark, or in Azure Machine Learning. Now, when it comes to some of that semantic information, I want this being a phone number or so, this is where we're also looking at a certain set of standardized semantic traits that are common, around geolocation, phone numbers, the concept of personally identifiable information, all those things. But aside from what we're standardizing, it's also extensible. So it will always be that you in your organization, you have certain special objects, and so we will basically make sure that you can extend it, you can use the mechanism, and the CDM, the object model, is ultimately has a programmatic way of expressing, extending, and then also reasoning over it. It's just some of the out-of-the-box tools and experiences that we built. They wouldn't have, user interface accelerators of taking advantage of this. Whereas with geolocation, yes, it would take advantage in a business intelligence experience of saying, oh, this is a geolocation. Yes, let me suggest a map visualization for this. So there's things where you can extend it, but then if the built-in support around tools may not understand your specific things, but it would still surface. So as a developer, you will still be able to leverage that. And you can see some of the beginnings already on the GitHub repository where we have annotated things with certain semantic metadata, but ultimately it's all open. You can further extend it.
You can create your own trait. Create your own trait, and the only difference is, as Robert said, the tools that already know that the geolocation is something to react to will not be able to understand it, but your own algorithms will. And you will carry that metadata along with the data. You don't have to rediscover it again, because traits are also extendable. You can create your own. If I define a trait on some column, can that trait refer to other columns?
Yes, you can. Yes. So you can basically say, this column here is described by, in more detail, by another column as part of this data model.
You can define an entity to be referenced as another entity. For example, you can define an address as an entity and reuse that in all other entities that use address. And you can further decorate them along, so you're not constrained by the one that you use. You basically have the least common denominator that understood through your entire org or entire set of tools. But if you want to make a specific entity or an attribute very specific, you can do that as long as you bake support for it throughout your reporting. So you basically need to tell your ML algo, what have you, that this truck is making right turns, for example. Or you may define it as a truck.
Okay.
We have a gentleman
on this side.
I think.
Hi. So my question about common data model is if customers are already implementing their metadata management in Azure Data Catalog, should they be focusing on switching out of Azure Data Catalog and moving more towards Common Data Model, or should they continue to invest in Azure Data Catalog?
So I would say they should continue to invest in Azure Data Catalog, right? What we are working towards is, I guess, the next version of Azure Data Catalog will automatically crawl and understand that metadata. So anything that is in CDM folders, it will just automatically populate things. So now all the existing investments that you have in Azure Data Catalog still has value. It's just we basically will simplify those things.
So what you're saying then is all these CDM folders will be able to be ingested by ADC v2
Yep.
when that comes out. Okay.
So
Excellent.
CDM is a metadata that will be cataloged by the catalog. Yep. Great.
Okay, let's take this one more, and then we'll still be available afterwards for.
I have similar question actually. So you mentioned that common data model will be also can be leveraged through Azure Data Lake. But my question is, does that just limits to the CDM folders? How do you actually have the data model on top of data lake? Because it's simply object storage or let's say file storage. Do you need a separate engine on top of that to have a data model abstraction?
So Azure Data Lake itself is ultimately file-oriented storage, and especially the Gen 2 that is generally available at this point, but offers you hierarchical storage, so you can organize things in folders. A CDM folder is really a folder, just a regular folder, except it has well-defined, well-defined metadata placed in that same folder. And there's tools such as Power BI Dataflow that automatically generates it, that automatically consumes it. Similarly, other Azure services automatically generating and consuming it, and there will be more over time. Now you can also programmatically, if you want to, you have your own system and you would want to just directly programmatically generate it. We have an object model that can help you with that, of how you just generate that metadata description, and other tools will just recognize, oh, okay, this is how to better understand your data. So from that perspective, Azure Data Lake helps with providing a single place, where you can put all your organization's data. And you can also, even if you have data that just lands without any metadata, you can have another process that basically adds metadata later, So all those things are possible.
Thank you.
Okay. Thank you, everyone. We'll still be around for a few more questions here on the podium.
Yeah, visit us at the booth.